Okay, class, today we're going to be doing lesson 4.3 addition rule. This is finding the probability of one of two events occurring, or even both, okay? It uses the word or. So we have the probability of A or B. Now guys, sometimes A and B cannot occur together, and other times they can occur together, okay? So probability of A or B. This is the probability of the first event or the probability of the second event. And I'll explain how they can go together. So, it's the probability of A or B within a single trial or with both. Now, compound event is any event combining two or more simple events. Okay, so this is a compound event. Combines any two, any event combining two or more simple events. Now, remember the drug screening thing? We have those that use, they got the positive results and they have negative results, and those that don't use positive and negative results. So this goes back to past videos, okay? We want to find the probability of a positive test or that they use. That they use drugs. Okay? So we're going to find the probability that it's positive or they use drugs. Now, is it possible for it to be both? Absolutely. So listen, thinking about how to do this probability without knowing any rules, what we would think of is we need to add together all the positives and all of the people that use drugs. In other words, we have to add 44 plus 90 plus 6 and put it all over the total. We won't use 44 twice when we're talking about those that use. We will only use it once, so since we thought of it here with the positive results, those that use, we just add once with the 6. So we would do 44 plus 6 plus 90 all over. There are 1,000 participants here. When we solve that, what we end up getting is 140 over 1,000. You hit 140 first in your calculator, hit the divide button, punch in 1,000, enter, and you get 0.14. And that's your probability that you will get a positive result or that the person uses drugs. Okay? So since it's possible for both, we have to consider both options in that. Now, just remember, the biggest thing is if you do it that way, you have to only count an entry once. Let me give you a formal rule for helping us find these type of probabilities, okay? The probability of A or B is going to be the probability of A plus the probability of B minus the probability of A and B together, okay? Probability of just A plus probability of just B minus the probability of both of them occurring. Now, another way that we might see some of these written, this is often written like this. This means A union B, union meaning or, okay? A or B. This A and B, that one's sometimes denoted as A intersecting B. It's an upside down U. This is an right side up U, okay? This means A and B because they intersect, right? If they're intersecting, it means both of them. All right, so anyway, that's just one way you might see these written, just to have that for your notes. Now, disjoint or mutually exclusive events. Disjoint or mutually exclusive, I'm used to calling them mutually exclusive. These are events that cannot occur at the same time. For example, being a registered Democrat and being a registered Republican, you can't be both of those. And so they are mutually exclusive events. Being registered as one or the other. An example of something that's not disjoint is for example, a person taking a statistics course and a person being a female. Well, that person can be both, right? and so they're not mutually exclusive events. Now, complementary events in the addition rule. Here's some rules for us to know for complementary events and the addition rule. First rule, if you were to take the probability of A and add to it the probability of its complement, remember that means the complement with a little line over the A, that is going to equal 1. Another rule, if you took the probability of the complement, or if you're trying to find the probability of the complement, that is 1 minus the probability of A. And then the next rule, if you want to find the probability of A, that could be found by 1 minus the probability of the complement. And we're going to focus a little bit on that one right there here, but here's an example of how this kind of works, okay? The Harris interactive poll finds that the probability of randomly selecting someone who believes in the devil is 0.6. So someone who believes, I spelled that wrong, second, has a probability of 0.6, okay? Find the probability of someone who does not believe. Well, the probability of someone who does not believe is the complement of this. So since this is, we'll consider this the probability of A, that the probability of A being they believe in the devil, the probability of not believing in the devil would be looking for its complement, which would be 1 minus the probability of A. So 1 minus 0.6 gives us 0.4. There's a 0.4 probability that people do not believe in the devil. Okay? Alright, so that's just an example of the complementary events using the addition rule. Alright, that's it.